So, today we're going to talk about how to use percents in a slightly different way. We're going to talk about how to increase and decrease values by a percentage, which is a little more difficult or a little different than it might sound. So, for example, if we have a static increase, and again, static just means a normal non-percent number. So if we have Jay had a salary of $30 a week and was increased by $5, how much is his salary now? Well, that's just 30 plus 5 is $35 per week now. So you just take the starting amount plus the increased amount and you get the new amount. Static number is pretty easy. But percent's a little different. If I say Jay had a salary of $20 a week and it was increased by 5%, how much is his salary now? I can't just do 20 plus 5 because it's 5%. Remember, percents are always linked to something. This 5 is actually linked to the 20. I'm saying I'm going to take 5% of this number and then add it back into that number. So percent increase and decreases are a little bit different than they might seem at first. They require a little bit more finesse and fine-tuning here. So again, we can't just do 20 plus 5% is equal to 25. That does not work, okay? Because again, this is 5%, not just $5, so this does not work. So how do we do this? Well, there's two methods we do for both percent increase and decrease. One is a one-step method, one is a two-step method, although the two-step method isn't really that much longer, so it's really not a big deal if you choose to use that one. The two-step method goes like this. So we want to increase 30 by 5%. We're going to take 30, and we're going to times it by 5% as a decimal. So we're going to take 5% of 30. We're going to figure out what is 5% of 30. So we're going to do that real quick. What is 5% of 30? 30 times 0.05. That is 1.5. That is 5% of 30. Then because it's an increase, what we're going to do is we're going to take 30 and we're going to add to it the number we just found. We're going to add to it 5% of itself. We're going to add 5% of 30 to 30. And that will give us a total increase of $31.50. Put a little zero here just to make it a little bit more clear. I'm going to put a zero back here too because we are dealing with money, so I should put 2 units. So that is the two-step method of finding the percent increase. You take your number, you multiply it by the percent you want to figure out. So if I want to increase it by 5%, I multiply it by 0.05. If I want to increase it by 15%, I multiply it by 0.15. Because again, what I'm doing is I'm taking the number and increasing it by 5% of itself. So I first need to figure out what is 5% of itself, or 10%, or 20%. Now the one-step method is, again, the difference between knowing and understanding. The one-step method is if you understand this, then you can manipulate it a little bit. Because what does increasing by 5% mean? Increasing by 5% means I want 100% of 30, and then I want 5% more. Right? That's what increasing by 5% means. I want 100% of what I have, and I want to have 5% more. So in total, what I want is I want 105%. I want the total amount I started with, and then 5% more of that amount. So what I can do here is I can say, well, basically I want 105% of 30. I want 105% of 30. Well, how do I do that? Well, what's 105% as a decimal? 1.05. Remember, move the decimal point up twice. This is one of those special ones where there's a number in front of the decimal point, actually. If you want to find the percent of a number, what you do is you take the number, just as we did in the other method, take the number, multiply it by the percent as a decimal, and in this case, you get 30 times 1.05, which gives you straight to the answer of 31.50. So this allows you to get straight to the answer in about one step, because this really isn't a step here. So about one step to get straight to the answer here, because that does the addition and multiplication all in one go. So this method here, the reason this is one step is because this 1 in front of the decimal point, this 1 takes care of the addition as well as the multiplication. Here we had to do it twice. Once with the decimal, multiply, and then we add that number back in for our second step. But over here, because we slapped the 1 in front of it, we can actually just go straight to the answer. So another way of thinking about this would be the one-step method is take your percent, change it to a decimal, and then put a 1 in front of it. And then multiply that to your original number, and that will give you straight to the answer. So take your percent, change it to a decimal, add it to 1, and then multiply the number by that. Now again, to understand this method requires a little bit more work. The two-step method here is pretty straightforward. You take 5% of 30, you add that back into 30, and then you get 5% increased of 30. Here it requires a little bit more work to understand why the shortcut works. The method itself isn't too bad, but the shortcut requires a little bit of thought. Decrease is very similar. Put a line down here. The two-step method is almost exact same. Decrease 40 by 20%. So I'm first going to take 20% of 40. I can't decrease 40 by 20% if I don't know what 20% of 40 is in the first place. So 20% of 40, so again you do 40 times 0.2, or 40 times 0.20. Remember, it really doesn't matter if I have that extra decimal there. And you get 8. And then, because it's a decrease, what I'm going to do is I'm going to take 40 minus 8, and that will give me 32. So decrease is the exact same thing as increase, except you subtract rather than add for your second step. The one-step method is a little different. It's not quite the same. You can't just subtract the number by 1. Well, actually you can, so we'll get to that here. So the one-step method, I want to decrease 40 by 20%. So if I think about this in terms of percentages, I start out with 100% of what I want, right? That's the 40. I start with 100% of what I want. I want to decrease this by 20%. I want to decrease this value. Remember, this is actually 40. I'm just thinking about it in terms of percentage. So I have 100% of what I want. I want to decrease that by 20%. So how much is left over if I do that? If I have 100% of what I want and I decrease it by 20%, then I have 80% left, right? So what this is really asking is, what is 80% of 40? Because if I decrease 40 by 20%, that means I have 80% left over. So I'm going to do 40 times 0.8, and that gives me 32 right away. So this is asking about the leftovers part here. So if you're doing a percent decrease, what you do is you ask yourself, what is left over after the decrease has been done? After I decrease it by 20%, what's left over? Well, 80% is left over. So I'm going to figure out what is 80% of what I started with, because that's how much I have left after the decrease. Another way of thinking about it is you take your percent, you change it to a decimal, and this time you subtract 1 by that number. Rather than adding it like we did before, we take 1 minus that decimal, we get 0.8, and then that's the number that we use in our multiplication. So for percent increase, we did 1 plus 0.05, 1 plus our percent increase to get our multiplier. For a percent decrease, we do 1 minus that, because again, it's a decrease, not an increase. But this method here gets you the leftovers, which is what you're really looking for. That's why it's a one-step method here, because you're looking for what's left over rather than what's the actual decrease to go about it. So again, a little bit more difficult to understand, but it saves you a step. So how are these used in problems? Well, let's take a look at a few here. Bill's earning a salary of $12 per hour. He gets a 15% increase. How much is he earning now? So 15% increase. I'm going to do 12 times 15% is 0.15. I'm going to get my value there. So 12 times 0.15, that gets me 1.8. And then I'm going to add that back into 12 because it is an increase. So increase this by 1.8. And that gets me 13.80 or $13.80. Again, very quick even for a two-step one. For the one-step one, what I would do is I would do 12, 15% increase. So I'm going to have 1 plus 0.15 because I'm increasing it by 15%, which is just 12 times 1.15, which is also $13.80. So again, one-step method, I kind of did this in 2 steps just so you can see where I'm getting the 1.15. Usually people are okay if you just go straight to this step right here, the 12 times 1.15. That way it is actually a one-step method rather than a two-step method. But I just wanted you to see kind of where I'm pulling this 1.15 from. It's 1, which stands for 100%. So 1 plus the percent that I want to increase by, and that's where I get the decimal from. The decrease is much the same. So we have a clothing company who's donating their excess inventory. They have 240. They're going to donate 30% on Monday. How much will they have left at the end of the day? Well, I'm going to have 240 decreased by 30%, right? Because I'm donating 30% of that 240. So I'm going to lose that. I'm going to donate that. It's going to be gone. So the percent decrease, so I'm going to take 240 times 0.3. Again, the percent is 30%, so I have to times that by 0.3 or 0.30 as a decimal here. So I get 72. Then it's a percent decrease, so I'm going to take 240 minus 72. And that should get me how much is left over. So I get 168 pieces of clothing left over. Or again, you could do the one-step way, which is 240. I donate 30%. That means I'm going to have 70% left over, so 0.70, because I have 70% of the clothing left after I donate the 30%, and that will also leave me with 168. So again, either method works to get you the exact same answer, and the way we got the 70, again, if you're not sure, is we took 1, which again stands for 100%, minus 0.3, and that's where we get the 70 from, or the 0.70, I should say. Now, there is a slightly different wording of this problem that requires you to do a slightly different method here, because what we're doing here is we are figuring out what is a value after it's been increased or decreased by a percentage. We're taking the percent increase or decrease of something. Another type of problem that sounds very similar but is fundamentally different is this. If we want to figure out what the percent increase or decrease was, that requires us to do a little bit more work. Or not a little bit more work, but a little bit of different work. So take a look at this problem here. It says a bookshelf in a library has 20 books. Last week, after getting some more books in, it now has 45 books. What was the percent increase? So this sounds very similar, but it's actually very different, because if you notice in these problems back here, they give us what the percent increase or the percent decrease was. They give us those values. They're saying, here's what you start with, here's the percent increase, how much do you have now? Or here's what you start with, here's the percent decrease, how much do you have now? This is saying, here's what you start with, here's what you have now, what was the percent change? Not how many more books, but what percent change happened. So for this problem here, when we want to figure out what is the percent, it's asking what is the percentage, not how many books, not how much money, it's asking what is the percentage. For that, what we do is this little formula right here. I should actually put a times 100 because it should be a percent answer at the end. But it's big minus small divided by the original. Now, what does big minus small mean? Well, in each of these problems here, you're going to be given two numbers. One is going to be bigger than the other. So you take the bigger number first, minus the smaller number second. That goes on top. And the bottom is how much you started with. That's why I say it's the original. How much you started with. So in this case, my starting amount would be 20, because I started with 20 books, and then I ended with 45. So 20 would be my original, and it would also be my small. So you're going to use a number twice. One of the numbers is going to be on top and bottom. Just one, though. And this formula is the same for finding both the percent increase and decrease. It works the same way. Because the reason is we do big minus small, so our answer is always going to be a positive. So we're going to say it was a 5% decrease, or a 5% increase, or a 20% decrease, or a 20% increase. We're never going to say it was a negative 5% increase, because that just doesn't make sense. We can't have a negative percent increase, and we can't have a negative percent decrease. So that's why we always do big minus small, so our answer is always going to be positive. So again, these sound very similar, but they're fundamentally different. Let's take a look at what I mean here. Let's take this problem here. A book in the shelf in a library has 20 books. Last week, after ordering some books, it now has 45. What is the percent increase? So I'm going to start with my big number, 45, minus my small number, 20. I'm going to divide it by how many books I started with. So I started with 20 books. That's what's going to go here. So the top part's pretty easy. That's just 25, 20, And then I divide these two. 25 divided by 20 is 1.25. And because I want my answer as a percent, I'm going to times this by 100 because I want the percentage, not just the decimal. And I get 125%. Which, if I look at that for a minute, makes sense because my books more than doubled. I had a bigger than 100% increase. 100% increase would be going from 20 to 40. It's just doubling. But 125 means I more than doubled, which I did. I more than doubled my books, so it makes sense to have 125% increase. But this last part here people often miss because you are looking for a percent answer, not just a static number. So you have to make sure you multiply by 100 at the end. But again, we're asking, if you ever hear your problem say, what is the percentage increase, or what is the percentage increase, that's when you do this formula here. If it just asks you how much you're going to earn now, or how much you'll have at the end, that's when you do this method right here. That's when you actually use the percent you're given in this problem. But if they don't give you the percent, if they go ahead and ask you what your percent is, then you use this method here. Same thing down here. A hiker's rations go from 30 packs to 12 packs. What's the percent decrease of his rations so that he doesn't die from starvation, right? So, big number, 30, minus small number, 12. My original in this case is the 30 packs I started with, so I'm going to put a 30 down here. 30 minus 12, that's going to be 18 if I'm not mistaken, which I don't think I am. And then I'm going to take 18 divided by 30, which is 0.6, times 100 to get the percentage, which is 60% decrease. So he decreased his packs by 60%, so hopefully he's 60% of the way done from his hike, or else he's not going to have enough packs to go around. If he's only 10% of his hike done and he's already used 60% of his food rations, it's probably not good. But either way, it works for increase and decrease. There's no change in what you have to do for percent increase and decrease like the other ones. You use the same formula, the same routine. Just make sure you're aware of what number is going to be used twice. What number is your original number? Because that's going to be the key point there to make this problem work. So two very similar sounding problem types, but two very different processes. And again, it all boils down to what is it asking you to find. If it's asking you to find the percentage or the percent decrease, if it's asking you to find this, if it says what is the percent decrease or what is the percentage increase, then you use this method. This big minus small over the original. This is to find the percent. If it's not, if it's asking you to increase something by 15%, or if it's asking you to decrease something by 30%, then you use this method here, which is either one or two steps depending on which one you want to use. Hope you enjoyed the video. Have a good day.